The following is Fall 2011 Math 21 Test 3, number 5. You are given a probability distribution there, and the question is, extend the table and compute the expectation of x. The expectation of x, by the way, is the same to the mu. And var of x, variance of x, that's the same to sigma squared. Okay, of the following probability distribution. Now, you will see that the way we do the extension here is actually the same to the way we did number 4. Okay, but the good news is here the probability already given to us. In number 4, the probability is something you need to find yourself, right? Okay, now let's do the extension. The first extension will be p times x, and then the second extension will be 3 other columns, right? Okay, now then later on I will do the, let me extend this here, the product of xi pi, and then I will get the mu, and then xi minus mu, and then xi minus mu squared. Lastly, the probability multiplied by that the square of standard error. Now this is xi pi xi minus mu, then xi minus mu squared, and the probability times xi minus mu squared. Okay, now that one you have to memorize. Okay, that one you have to memorize. Now let's see. The product here, this will be 0.30, and then 3 times 0.35, that will be 1.05. This is 1.5, this is 1.20, right? Yeah, oh, by the way, when I add this, this equals to 1, right? And then when I add this later on, 4.05. Use your calculator, of course. Therefore, the expectation of x, which is equals to the mu, that is 4.05. Okay. Now then I will use this to subtract from each category there. 2 minus 4.05, that's negative 2.05, negative 1.05, and this one will be 0.95, and this one will be 1.95. And then from each one of these you're gonna square it. You need to take your time to square it, right? And then after that multiply by the probability. Okay. Take some time, but this is what I have. When I square it, I get 4.2025. 1.05 being squared is 1.1025, and this will be 0.9025, and then this is 3.8025. Basically I square each one of them here, and then the next column I will multiply by the corresponding probability. That will be 0.630375. Now notice that I round to 6 decimal places here. If you make it into 5 decimal places, you are okay. Then it will be 0.630338. Okay, but if you want to make it into 6, go ahead. 0.3858875, and then next one will 0.27075. If you wonder how I get these numbers, I multiply this p and the corresponding square error. Okay, multiply this, and lastly I multiply this. That will give me 0.7605. Now if I add this, this will be 2.04750. However, if you round it to 5 decimal places here, this will be what you get, and for the second row this is what you get. and therefore when you add later on, if you round strictly to 5 decimal places, I think you will get 2.04751. Okay, so it differs at the 5th decimal place, but it is actually not that crucial. Now, if you give me either one, I will be fine. Just give me a reason why you do either one of them. And therefore, the variance of x equals to sigma squared, which is that number, right? If you don't do any rounding, this is what you get. But if you do some rounding, this is what you get. To 5 decimal places, and this is what you get. Notice that the question is not what is the standard deviation, right? Only the variance. So you can stop there. This will be our answer. This is acceptable. This is the estimated mean. Okay, this is for fall 2011 Math 21 Test 3 number 5.